to your needs. And the other thing is, of course, you can also modify or edit the code without modifying the existing core base. Just like profit, neural profit is also decomposable with all time series components like trend, seasonality, auto regressor, laggard regressor, future regressor, and recurring events as well. This library is absolutely an updated version of profit because it uses deep learning models such as AirNet for forecasting time series models. Now, why we need exactly neural profit? It aims to solve the seesaw of uncertainty. So what do I mean by here? I assume you are aware of AR models. So AR models are nothing new, but usually we would use linear regression fit with least squares instead of neural network fit with a backpropagation. ARNet mimics the traditional AR process with a neural network. So it is a single layer network that is trained to mimic the AR process in a time series signal, but at a very larger scale than the traditional models. ARNet also scales much better to the larger data sets and more inputs. For example, if you look at the below graph, it shows that the training time of ARNet doesn't increase exponentially when compared with AR order. So this is the ARNet graph and this is the AR order. It doesn't increase exponentially when compared with AR order. One thing I would also like to talk about here is about the p-values. So the p-values here are the number of the values used, number of the autoregressors used in the AR model, not that p-value which we associate forecast in the hypothesis technique. So this is something you should really keep things in mind. Apart from ARNet, neural profit also upgrades profit linear external regressors to feed foreign neural networks because deeper is equal to better, which means the better we get the model, so the better we get the results and the better we have accuracy. Last but not least, adding neural network to the profit has a downside because it increases the learnable parameters dramatically. To cope up with that, neural profit relies on PyTorch framework as a backend instead of a STAN, and it trained with stochastic gradient descent. So STAN is nothing but the state-of-art network which for statistical modeling and highly computational for statistical performance. And here comes the difference. So as the name suggests, neural profit is similar to profit, but it throws neural network in the mix to spice up things. When you are exploring time series data at any point of time, you will definitely encounter a popular package called Facebook Profit. So this library has gained a lot of popularity due to the fact that it provides a very good results in terms of accuracy and interpretability. And the best part of the Facebook Profit is it automates a lot of elements for the user, such as hyperparameter selection, feature engineering, etc. That is why this library is very straightforward to the user, like data scientists or any other folks who are playing with the time series data, or even for the folks who has very less knowledge, they can easily use this library. And when it comes to neural profit, the author also had the same thing in mind while developing this library to retain all the advantages of the profit while improving accuracy and scalability. So, and using ARNet to combine the scalability of a neural network with the interpretability of AR models. So here are some of the core differences which are featured in the neural profit comparatively with the original profit. The first one is like gradient descent for optimization. So neural profit relies on PyTorch as a backend, which makes model much faster. The performance of model will be much faster compared to with profit. And time series autocorrelation is modeled using the AR autoregressive neural network, which is again a very good advantage. And laggard resources are modeled using a separate feed-forward network. As I mentioned, it takes a separate feed-forward network for the laggard resources. And the model is also configurable to non-deep layer parameters of the feed-forward neural network. This is again a biggest advantage in order the performance will be like, massive. And it also offers custom metrics and losses. Apart from these features, another great feature of a neural profit is it gives a developer access to the AirNet library, which was developed by Facebook. So that's these are the core differences for the neural profit, which makes the model much faster. I think I have given so much GAN on theory. Let's straight away jump into the action now to see how neural profit performs in real time. So let me switch back to my code notebook now. So here is the code notebook for neural profit. So basically the goal of this notebook is to show you about neural profit and how it is used for time series modeling. And I'll also show some various techniques to visualize and manipulate time series data, and also show some important various techniques which are involved in neural profit. So when it comes to installation of neural profit, so there are similar ways you can do it. So the straightaway process is you can simply pip install neural profit, or if you want to run neural profit in a Jupyter notebook, you need to install neural profit live. So this will allow you to enable the live plot loss in the fit function to give live plot for the training and validation loss, so which you will be seeing in some time. And if you want to get an up-to-date version of a neural profit, so simply you just go to the GitHub page of a neural profit and clone the repository and start playing with it. So in this, so for this demonstration, so in my case, I have installed the live neural profit. So it took some time to install because this package is a heavy package and it uses Torch. So that is why the loading time requires 2 to 3 minutes of time. So which I have already installed here. Again, I'm running for you now, so you can see. So it takes 2 to 3 minutes time. Okay, it's already done now. Okay, cool. So basically this notebook consists of a two section. In the first part of section, we'll be talking about creating a simple baseline model of a neural profit. In other section, we'll dig into bit detail about neural profit and we'll see what are those things. Okay, so as usual, we'll import necessary suspects here. So I have imported libraries like mandas, matplotlib, cbon, and from neural profit, I have also imported random seed, and I have set random seed with random number to ensure that results are reproducible on subsequent model run. So here my random number is equal to 0, and I'm loaded my libraries. And for this demonstration, I have taken the retail CSV data, which is from neural profit page. So have run the data. So here are the first 10 rows and here are the last 10 rows of our data. So just like profit, neural profit also need to require some reformatting on our data frame before we pass to our model. So what I mean here is so we need to make sure that our date column is a correct data type, and which should be named as DS, and our Y parameter, which is the predicted value, should be named as a Y. So in our case, which is already done here, so there is no need to do reformatting in our case. So we can simply proceed further. So creating a simple model. So in neural profit, we can simply create a model and validate with very few less lines of code. So let's see that. So what I've done here is I've initiated a neural profit here. So there are so many options and parameters are available in neural profit, which we can pass to our model to improve our results. But for now, we keep things simple and let's build a simple model here. So I'm just initiated the neural profit model, and then I'm calling my fit function, and I'm passing my data and other three parameters called validate each epoch. So validate each epoch is nothing but whether or not to validate the model performance on the validation data for each epoch. So validity is a parameter, which is a float parameter between 0 and 1, indicating that the distribution of a data should be used for a training. And plot live loss is nothing but to get a live plot for training and validation loss. Frequency D is nothing but we are using a daily frequency here. Epoch is nothing but the number of epochs that should be used for training. So let me run this. So it takes few seconds to run it. Okay, it is running. So if you observe and notice how the plot and live loss are changing after each epoch. So did you notice that? So let me also rerun it again. If you notice the plot, okay. So if you see the plot, how the plot and loss values are changing after each epoch. So that's the beauty of a live plot. And now we'll generate a prediction. So to generate a predictions for a neural profit, we need to have a future data frame. So as the name suggests, we need to create a new data frame of the date that extends our original data frame. So what I'm doing here is, so I have passed my model and I'm creating a future data frame, passing my data here, and period is equal to 365, which means that I am creating a future data frame of a 1 year future data frame here. Then I am passing my future data frame to predict function so that it will return the forecast. So once I execute this, so here we got our future data frame. So if you also notice, so our data starts at 1992-01 and our data ends at 2016 1 May. If you look at our prediction future data frame, it starts at the May 2016 second and it ends with 2017 one. So we got a 1 year data frame now, and it also identifies the y hat predictions, trend, seasonal, yearly values as well. So that's again the beauty here. And one thing we should also remember here is it is common that no y and residual values to be none. So that is the expected behavior. So you will need to find that. So, so we have created a future data frame. Let's plot our model forecast. So it's very straightforward. We just need to pass the future data frame here and we are to our model.plot. So it will generate the plot here. So notice how model is able to learn the seasonal pattern for our retail sales data for on our feature data frame. And you can also plot the model plot component. So this process is known as the time series decomposition. So if you look at the trend took a very solid downward trend here. And if you also look at this graph, the seasonal ELT, particularly January is quite the busiest month comparatively with other months. So if you see the seasonality, December being the busy month comparatively with other months here. So these plot components are very important for domain experts because they visualize these plot components to see insight. They visualize this component to visualize on the overall forecasting process and adjust their model accordingly. So these plot components play a very important role in the model building. So 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 that's pretty much about building a simple neural profit model. So it's very straightforward and very easy. So you can check that. When here we comes to our next section. So in this section, we'll see why neural profit is so powerful. So when it comes to neural profit, so neural profit is especially powerful for time series forecasting because it takes additional information into account such as trend, seasonality, AirNet, and recurring events into account. So we'll see all these items one by one in action now. So for this demonstration, so I have taken a different data source away from Kaggle, which is called Nifty 50 data. So it's a Maruti company here. So I have taken the Maruti CSV, passed the Maruti CSV, and I'm reading my data here. So here we got first 5 rows and of a data. Then here you can see the quick info about all our columns which are available in our data frame and about date type, everything. And if you also look at the shape of our data frame, so we have total 4,427 rows and 15 columns now. Okay, as I mentioned earlier, we first need to reformat our data before we pass it to our model. So this is what I am doing here. So I have created a new data frame variable here, and from my original data frame, I am selecting date and VWAP column. So VWAP is nothing but the volume weighted average price. So volume weighted average price is a trading benchmark for traders that gives an average price of a security traded throughout that day. And this price is really important for traders because it gives an insight to both trend and the value of a security. So for this demonstration, so I am taking my future prediction price as a VWAP. So then, as I mentioned earlier, so date should be the current date type. So in our case, the date is actually an object, so it should be a date time stamp here. So that's the reason I'm converting my date from object to date time. So this is what I have done there. So once I execute this, so we'll get a date and volume weighted average price values. So let's start with the trends. so so what I'm doing is I've selected my data frame and passed this column and just simply plotting to see how my volume weighted average price has been. So if you look at this graph, it shows a general increasing trend with small changes where prices rise or falls sharply. I mean, like most of the graph looks a solid increasing trend where where there are certain places where you see price rises and falls sharply. So we can consider these as a change point. So with this in mind, we'll now train a neural profit model of our volume weighted to predict our volume weighted average price by only focusing on the trend as our first version of our model. So we'll take, so we will now build only considering a trend as our first version of a model. So then what I'm doing is, so we cannot pass date as a directly in our date column. So as I mentioned, so we just need to rename these columns into DS, and our predicted parameter should be as a Y. So this is what I am doing now. So I have done this. Now we got date as a DS and volume weighted average price as a Y. So we are all good. Let's now create a trend model. So with neural profit, we can create a trend time series model by passing only few arguments here. So I initialize a neural profit model here, and I'm passing few parameters, which is like n change points trend. N change points is nothing but specifying the number of points in the broader trend where rate of price increase or decreases at any point. So trend rate is nothing but it's a regularization parameter that allows to that allows to be plotted of a changing point selection. So this is what it happened, and I'm giving this yearly, seasonal, daily, seasonal T as a false because right now we are focusing only on the trend. So the seasonality should be given as false. So having then we're done with the initiating a model, then I am passing my fit function to our data frame and also the other parameters which we have already seen above in our first section. Okay, now let me run this. So if you notice this loss plot, it looks much compromising, but however, it seems like after a lot of volatility, the model has converged. So, so what we can do now is what we can do to understand better trend pattern here is we'll visualize our model predictions now. So in order to do that, what I have done is I have created a custom function called plot forecast, where I am passing my model data, periods, historical predictions, and highlight steps ahead is good enough. So model is nothing but our trained neural profit model here. Data is nothing but the data frame which we have used for the training, and period is nothing but the number of periods which we want to forecast. Historical predictions is nothing but whether we want to plot model predictions on a historical data. Highlight steps ahead is nothing but the number of steps ahead of a forecast line to highlight. So this is only used in autoregressive models. So there I am creating my future data frame here, and where I am passing my data and periods and historical predictions. Then I am passing my future data frames to predict function so that it will return forecast now. And I have also written a quick conditional statement here because so what this means is if highlight step is head is
Kalyan, we can't.
yeah,
We sorry to interrupt.
yeah.
We can't hear you.
Can you hear me now? Can you hear me now? Can you hear me now?
Yes.
Okay. So is it audible now? Is it audible now? Can someone confirm in chat, please? Okay, perfect. Thanks. Okay, so where I am, so I'm talking about this conditional statement here. So my conditional statement here is if highlight step head is not none here, so I want my model to highlight a step of head each for each forecast line. So I want my model to highlight all these things. Otherwise, I just simply want to plot my model forecast. So this is what I have done. Let me run this. Now I am calling my plot forecast function where I am passing my model and data frame and giving period as 60. So now we can visualize, we can visualize our stock price based on historical data and as well as its forecast data. So this plot includes the forecast plot on historical as well as a future. So let me also so first let's see this. So it is evident that the model is able to capture a general increasing trend for our stock price. But however, if you look at the model seems to suffer with underfitting here, particularly if you look at 2019 and 2020 period that was likely used for validation. So we can also better analyze this plot. So I'm again calling my function, passing my model, data frame, period, historical. So this is a forecast plot without not showing about the historical prediction. So this looks like a solid increasing trend here. But if you but something I'll tell you in reality that if the stock price was that easy to predict, so based on this straightforward increasing line, if stock price was that easy to predict, no one in the organization would generally hire a financial advisor to manage their portfolios. Makes sense, right? Because this shows a solid increase. Like it was quite easy to predict here, but this is not happen in reality. So what we'll do now? So what we make our model much better. We'll pass some seasonal parameters here to make our model more realistic. So let's do that. So here comes the seasonality. In most often, time series involve seasonal patterns, which is even true for stock market prices as well. So we'll pass some yearly seasonal parameters to our model and see how our model performs. So again, I will initialize my neural profit model and rest all parameters same. Only thing I'm changing here is the yearly seasonal parameter true, which means that I'm passing my yearly seasonal parameter and rest all remains the same. Let me run this module. So let's look at our live plot now. So the live plot seems compromising again here, and so it's still no it looks still some volatility here, and so let me call my function and passing my model data frame and predicting the 60 day, which means I want predicting for next 2 months, and history is nothing but so where I want to have historical data as well. So let me plot this. So let me also plot the forecast plot here. So if you look at based on the above two plots, the model looks a bit realistic, but it still suffer with underfitting here. So the model is still underfitting in this particular year. And if you also look at the forecast plot, it shows a smooth curve which is of a yearly seasonality here. But in reality, there are very rare instances where stock price moves so smoothly. If you remember, most of the stock prices look with uneven and jagged lines. So if you they don't look like very straightforward lines or in smooth curve. So most of the lines will be zigzag and or uneven lines. So this is so what we can do better in order to improve this model. So we capture all this volatility now and by using AirNet model and we'll train with this AirNet model. So what is AirNet now? So AirNet is an auto-regressive neural network model that is especially used for time series modeling. So auto-regressive models are a class of models that are able to predict the future values of a variable based on its previous patterns. So we can train our ARNet model by passing a few parameters here. So let me initialize my model here. And so here I passed n forecast and n lag. So these are the parameters which I passed, which is nothing but, so we are training our model and our model want to predict our prices of Maruti from the historical price to future 65, historical 60 days to future 60 days, which means that, so I want my model to predict based on historical 60 days to future 60 days. So these are not, this is what it means n lakhs and n forecast here. So rest all arguments remain the same. And again, now I am fitting my model here. So let me run this. So once I execute this, so we'll get a smooth loss MSC, MAE values here, and we'll see that now. It takes a few seconds because this is quite a heavy one, right? So definitely take some time to run. So please be patient. So far, if you have any questions, so feel free to drop out in the chat. So I'll be happy to answer in case if you have anything. So since the epoch values are 100, so it takes each epoch to run at least few seconds. Okay, so here we got our loss values, mean absolute error values, mean squared error values, and reg loss values. So you see the values have a different volatility. So instead of looking at this number, so let's plot this to understand things better. So let me plot our ARNet model here, forecast model. So see the graph here, and let me also plot this model forecast plot as well, and then we'll talk about this. So based on the above two plots, okay, so this is a forecast plot and this is also a forecast plot including historical prediction. So based on the above plots, our ARNet model makes predictions more realistic here, makes more realistic here, and it also managed to capture the uneven lines in the moments of the stock market. So if you see the forecast, the model is able to capture the uneven lines in the moments of the stock market. So that is the beauty of the ARNet model here. So this is quite a good model so far, but what we can do even better if we want to improve this model. So we can take our recurring events into the consideration and see whether we can still improve our model. So let's jump into the recurring event. So often when forecasting time series models, we take recurring event into the consideration. So this is what I'm doing here now. So again, I've initiated the neural net profit model and passed all these parameters here. Then I'm configuring my model to take the dates of the holidays into the account now. So I'm giving Indian holidays here. So because since Nifty is a national stock exchange of India, so I am considering Indian holidays here, and I'm also passing a parameters called lower window and upper window, which means that I want my model to capture the prices impacted before and after the holiday, which means that if today is the holiday, I want my model to capture the prices impacted yesterday as well as tomorrow. So this is what this parameter means here. Now I am fitting my model here. So let me run this now. So it takes a few minutes to run to get our losses and errors as well. So yeah, it's going now, going. It is 52. Okay. So the thing is the processor should be a bit faster so that we'll get the results quite quickly. Unfortunately, my processor is a bit slow, so that's the reason it's taking some time here. So we got values of our loss function, mean absolute error, mean square error, reg loss here. So in order to understand this, so let me plot now our forecast. So so this is how our plot looks even after considering recurring events into the consideration. Let me also plot the forecast data here. If you all see, it also captured some movements here. But if I look at the AirNet graphs and also the recurring event graphs, there is no much impact here, even though after considering real recurring events into the consideration, there was no much change in the price. It remains the same. So, so what I want to conclude, tell you here is predicting the stock price is not that easy, but still our model has done a good job in terms of capturing a general trend patterns for our stock price. So due to the day-to-day volatility of the stock market price, I generally not recommend to use this model for your own trading, but I believe that this is a good demonstration of the capabilities of telling about the neural profit. Lastly, what I would like to tell you is there is so much thing that you can explore, do with neural profit, but hopefully this is something that you can. This is at least something that you can get started with whatever the explanation which I've done so far. So So that's pretty much about on hands-on. So let me again jump to my slides here. So here is a roadmap for neural profit. So one thing before I talk about roadmap, so there's something I should also mention here is this library is still new, and a lot of changes can happen. So you should remember one thing here is not all the features which are there in the original profit are already implemented in this neural profit. So for example, so logistic growth for trend component, this is something they need to add the feature, support manual data, incorporate time series feature, improve forecast accuracy, model bias modeling, and unsupervised anomaly detection. So all these features are yet to be added in neural profit. And if you want to refer the neural profit, so go to their page and GitHub page, and also look at the AirNet model page. And there is also a great article about comparing neural profit and profit differences. So feel free to explore and experiment, and let me know if you find out any interesting results. Feel free to share with me. I'll also happy to learn and gain things from you. And thank you. And of course, it's always take the time to take seriously. And that's pretty much from my side. I'll happy to take questions if I have anything. I'll stop sharing my screen for a moment now.
Yeah, thanks for your presentation. So, with the participants have any follow-up questions to Kalyan, you are welcome to contact him. Yeah, we will share his slide on our conference website, and also we will edit the video and then upload to the YouTube as well. Yeah.